Hello there, I'm Thomas Hatsios, German-American pilot flying the Boeing 787-900 to 9 flight from Zurich International Airport. We're going to be able to fly in Zurich, Switzerland and Germany. Then coming back to the Zurich International Airport, runway 1449, Lszh localized and landing now in the cockpit for the pre-takeoff preparation of the quality wings, Boeing 787-900 and Microsoft Flight Simulator X. I'm going to start showing the cockpit instruments and displays and the functions of the Boeing 787-900 aircraft. I'm going to start with the primary flight display that displays the airspeed indicators. The airspeed selected from the autopilot flight indicator system panel, the ground speed, the radio altitude above the ground level, the barometric altitude above the sea level, the target altitude selected from the autopilot director system panel, the ground speed, the barometric pressure of the outside atmosphere, the vertical rate of climb and descent of the aircraft in tens, hundreds and thousands of feet per minute, all the steepness of the trigonometric angles in degrees, you can climb and descend. We have also the artificial horizon with the pitch ladder in degrees, the bank angle in degrees, the horizontal localizer and the vertical glide slope. We have the Lszh localizer, the receivers, the onboard receivers receive the radio frequency transmitted from the runways we use for takeoff and for landing. So this places the horizontal localizer with the vertical glide slope and the Lszh localizer crossbars. They can align us with the runway magnetic north pole heading. So we have the Lszh airport, the Zurich International Airport in Switzerland. And runway 14 we're gonna use both for takeoff and for landing, so you will see the Lszh localizer frequency for that. We have also the flight director crossbars for manual guidance of the aircraft and the autopilot crossbars for automatic guidance of the aircraft. We have also the angle of attack of the aircraft as it flies and the flight mode and 0 with the autopilot and the autothrottle. Lateral and vertical navigation modes. We have also the HSI, the horizontal situation indicator that displays the magnetic heading and track, the integrated display with the flight plan. I'm gonna use the flight announcement later to create a flight plan. So we have the navigation display that displays the GPS position, the magnetic heading and track, the magnetic north pole and the geographic north pole and the magnetic variation depending on where we are in the world. You can see the terrain map with the terrain and weather reflections from the weather radar. So you can see the terrain with red, green and yellow color, the elevation of the terrain around you. With blue you can see the sea, the lakes and the rivers. You can see also the airports where they are located. So we have our own airport right now, the Zurich International Airport, the Lszh. You can see the 4-letter name of its airport, code name. We have also the navigation aids, the nav aids like the ADFs and the Bs, waypoints, voice stations. So we have the waypoints, which are horizontal and vertical navigation features. The aircraft is going to have to transverse or fly through some waypoints as we're going to be flying. So you will see how we're going to achieve that also. I'm going to use the flight management computer to input the waypoints we're going to use for flying. This aircraft in the LNAV and the VNAV function in the lateral navigation and vertical navigation modes, which are interconnected with the autopilot and the autothrottle, autopilot flight director system, and also the autothrottle for automatic navigation. So it will follow automatically the flight plan we're going to be creating in a horizontal and vertical profile, or we can fly it manually if we need. So you will see also that in the navigation display we have the display of the flight plan that I'm gonna create in a couple of minutes. So I will use the flight management computer to input the data of the aircraft for this flight, and you will see the purple line of the flight plan with the legs of the waypoints, one waypoint by another. Is gonna be connected in a line. It's gonna give us the flight plan the aircraft is gonna have to fly. We'll make also the settings of the autopilot flight director system panel. So I will set the data of the aircraft for this flight, the takeoff gross weight, that includes the empty weight plus the passenger plus the cargo plus the fuel on board, where the fuel is stored in the left and the right wing, in the center tank, how much we have it, 30% in the left and in the right wing tank, also 10% in the center tank. The flight management computer is going to calculate automatically the loads from the fuel and also from the compartments of the cargo and the passenger. It's going to give us the center of gravity of the aircraft and the aerodynamic chord position, the Mach, which is about 33% of the forward wings. Aerodynamic chord is the position where the maximum aerodynamic lift occurs in the forward wings. It's also the position where the stall will begin in flight. The airflow will become detached in the top surface of the wings, so you can monitor here always You have here the airspeed indicated in the primary flight display, and you can see also here's the airspeed indicated, the airspeed selected from the autopilot directives. How you see the stall speed is gonna be here, like with a yellow and red indication. You will need to have an airspeed above the stall speed always when flying the aircraft in non-call of attack. So it's gonna be less than that. So you will see also uh, you will see all these things that are displayed. So we have the center of gravity, the mineral dynamic core position. I'm gonna use 15 degrees of flat, and the flight navigator is gonna make calculations for the horizontal trim stabilizer. For takeoff is gonna be about 4.25 degrees. So we're gonna use the horizontal tail stabilizer. You can see here the horizontal tail of the aircraft. So we have the elevator, the control of the elevator for climb descent of the aircraft over here, and we have also the elevator trim stabilizer. You will see this function later when flying the aircraft. So I'm gonna show you also the flight controls. I'm gonna use the flight controls flying the aircraft. So you can climb and descend over here. You can see the elevator. Later you'll see the elevator trim, also the rudder pedals. So this is the full flight control surfaces. You can move around. I will talk to you about Newton's physics, aeronautical and aerospace engineering, and I'll derive some aerodynamics and aerospace and aeronautical engineering principles we need also for flying the aircraft. So I'll start explaining in a couple of minutes. So you will see over here. So we have the surface area of the wings hold the aircraft weight as we fly. As you can see, using the aerodynamic lift, we have the thrust from the engines that move the aircraft forward. We have the mean aerodynamic core position. The Mach is about 23% over here, where the maximum aerodynamic lift will occur in the forward wings. So also where the stall will become, the airflow becomes detached from the top surface of the wings. The stall begins is where we calculate pretty much the center of gravity, the vertical axis over here of the aircraft. The transverses over here, the longitudinal axis. So we have the longitudinal axis, as you see, the vertical and the lateral from wingtip to wingtip. So we have the lateral axis for climb, descent using the elevator, and the elevator or horizontal stabilizer trim sweeps used later. The rudder pedals for making turns around the vertical axis, yawing turns, and also we have the longitudinal axis using left and right side stick deflection, as you can see. So you will see all these things. You will see the flight controls, how I use the flight controls. So I keep talking about the aerodynamics. I didn't finish yet. So using the Newton's physics and brand new theory of fluids, you can see also. So the longitudinal axis, we have the horizontal stabilizer over here, the vertical stabilizer, and you can see the wings. The bottom surface of the wings is more flat. So also as the aircraft accelerates for takeoff, there is a lower airspeed using the Bernoulli theory of fluids below the wings. So there is higher air pressure below the wings, which pressurizes the aircraft weight and wings up into the air, as you can see, both wings. So also the top surface of the wings, as you can see, is more curved. So as we fly, there is a higher airspeed of air above the wings. So there is a suction and a lower air pressure which sucks the aircraft up into the air, the weight and the wings. So this is the basic aerodynamics and aerospace engineering we need to know. But I'm flying the Boeing 787 jet aircraft or any aircraft, pretty much the same. So I'm going to show you now the rest of the systems, the flight balancing computers. I was talking about the weight of the aircraft and the aerodynamic position, the center of gravity, the fuel on board, and the load and the cargo, the calculations from the flight management computers, the center of gravity also, and the horizontal trim stabilizer. So I'm gonna set the flight management computer in a couple of minutes. You see how. So I was talking also about the flight controls, how you can control the aircraft over here. So you can see I'm using the side stick to control the horizontal tail for climb and descent. Also make turns to the left, turns to the right. It's a fly-by-wire aircraft, so it has flight control computers on board. So when you move the side stick, you give an electric signal. Over here you have the flight control computers primary, pretty much like the Airbus. So you have the auto mode, automatic mode. So you have also the alternate mode and the direct mode, the mechanical backup mode. So you can see you can climb, descend, make turns in flight. You will move. Here you see the direct movement of the elevator, left, right turns over here. So you see the side stick deflection is proportional to the yoke. Both sides are interconnected of the flight controls for climb and descent. Also the control column, here the control wheels. Control column is for the elevator for climb and for descent, and the control wheel is for making turns left and right using the ailerons and the spoilers, and the rudder pedals using the rudder, the vertical tail of the aircraft rudder. And also for nose wheel steering, the ground is interconnected with the tiller until some airspeed. You control the nose wheel in the front of the aircraft to make turns like 76 degrees, and it's decreasing as you increase an airspeed for takeoff, like to 7 degrees above 40 knots, and then 0 like 70 knots. You have the rudder aerodynamically effective to like 45 knots. So you will see the controls. You can see both sides are interconnected, the captain and the first officer. They move together. They're not like the Airbus, you have the side stick priority unless you have a failure. So I will show you one more view of the flight controls of the Boeing 787, then I will make the rest of the cockpit and system explanation. So you will see now this side of the flight controls over here. So again you can see we can climb and you can descend. You can make turns to the left, turns to the right, like this. So this is how to control the flight controls, the horizontal trim stabilizer also. And now the thrust levers. Here you have the thrust control of the aircraft, as you can see. You can control the thrust levers forward and up. You'll see the engine's thrust increase or decrease. So you can control together like I do the throttle, the thrust levers, and the control, the side stick. So hope you like this side stick I use for flying, making turns left, right. So maybe I will show you on the outside view a little bit over here. So we climb and we descend, make turns to the left and make turns to the right. So climb, descend, make turns to the left, make turns to the right. also retract the flaps, also make turns again around the aerodynamic center and the thrust from the engines. So again, one more time inside, and then we go for the rest of the system. Maybe better view now. And the thrust over here. So now we have this is so much for the flight controls. Tonight I will show you the rest of the system: the horizontal trim stabilizer, the engines, the autopilot, flight director system panel, the flight management computer. So we have here, as you can see, the thrust levers also from the engines control. Maybe you have a better view now. What we do with that, with the engines control. So you see the engines thrust over here, and the left and the right engine, arc straight, forward or aft. So you can see also we have the horizontal trim stabilizer over here, the horizontal tail trim stabilizer. You can trim the horizontal tail of the aircraft, trim up this way, trim down this way. So you can use the trim switch for trimming up this way. You can see for trimming down this way. You can see also what it displays here. Elevator trim, left click down, right click up. So we have also the autopilot disconnect over here. And now the head-up display declutter. So you can see the airspeeds for the flaps also over here. Multifunction display switching. So we have also, you can see the horizontal tail elevator trim over here. You can trim the whole tail some aircraft, or you can trim the elevator only. So we have over here the autopilot flight director system panel and the auto throttle. We have the auto trim function from the Boeing 787-900Z aircraft. Since this is a fly-by-wire aircraft, it can trim itself using the flight control computers and the other systems like management computer, autopilot flight director system panel, auto throttle, the thrust levers, thrust position, command from the FAREX, the Flught or digital electronic control computers. So if you have a failure of the hydraulic systems over here, you can see in the overhead panel, if you have failure that affects the L2 or R2 horizontal stabilizer, you come down here and you open this guarded switch over here from normal to cut off, as you can see, and you use the alternate pitch string. So this is for all Boeing 737, 747, 757, 767, 777, 787 aircraft. So you turn from normal to cut off. You can use then the horizontal trim stabilizer here, the alternate pitch string, as you can see, or the manual. So this way you trim up the horizontal, the tail of the aircraft. You trim up, you pitch up the nose of the aircraft as you fly, and this way you pitch down the nose of the aircraft. So you have also the parking brakes, as you can see. So you use always the manual trim switch control over here for trimming the horizontal tail of the aircraft, as you can see. So this is the manual trim switch elevator. When fine, you trim this way or the other for balancing the aircraft in flight. Relieve the air pressure from the flight controls from the yoke and have more balance in flight. We can keep a pitch up or pitch down nose up of the aircraft, whether you want to glide or descend or hold level flight. So you would see also that. So also you're having more flight controls. Here we have, as you can see, the flaps position. You can see the flaps are moving. We can retract. We have them fully extended right now. We can retract them or extend them. We use the position of the flaps over here. So you can see how many degrees you wish to have the flaps position. So you will see the flaps position over here. Change indication. 18, 17, 15, 10, 5, and 1 and 0. So we have full 30 degrees over here. We have also the stabilizer, the landing gear, extend and retract. In the display, in the ACAS display, engine indication and crawler system display, we can see the flaps position 30 degrees, horizontal stabilizer trim position 4.25, the rudder trim, the outflow valve from the cabin pressurization system. So you see the landing gear here, extend and retract, now it's down. The alternate gear here, the lock override, the retract speed for the landing gear, the parking brakes, auto brake here, reject takeoff. You will see auto brake 1 for landing, or 2 or 3 or 4, whatever you select, or off. So you will see also over here we have the speed brakes, extend and retract, as you can see. We have them extended, as you can see, retract. We have the fuel control for the left and the right engine. The fire extinguisher for the left and the right engine, you pull out and switch. The transporter, the radio management panel over here, navigation radios, as you can see, for communication and navigation. We have also the rudder trim over here. So you can see also the overhead panel after that. So we complete. So you see the flaps are extended over here in the left and the right wing. They extend or retract together, and also the speed brakes are now retracted, now extended, which are also spoilers when we making turns. So this is all the flight controls. We need to know. I will show you now the autopilot flight director system panel, the flight management computer, the thrust for the engines. So I'm gonna continue now with the flight management computer. So I told you I will input the gross weight of the aircraft, the left and right wing, fuel on board 30%, center tank 10%. It's gonna calculate the loads from the passengers and the cargo, the mean aerodynamic core position, the Mach 33%, and also the horizontal stabilizer trim 4.25 degrees for 15 degrees of flaps, using this runway for takeoff, the Zurich International Airport in Lszh in Switzerland, and runway 14 both for takeoff and for landing. We're gonna have the runway we're gonna use, the runway length, the runway slope, the wind direction and speed, the barometric pressure, the density of the air and the temperature of the air. It's gonna give us the takeoff speeds V1, V-rotate and V2. Then we're gonna have the Cs, the southern and the departure waypoints and fixes that include horizontal and vertical navigation fixes for the initial departure and climb of the aircraft, altitude and airspeed constraints. Also we're gonna have the climb to the cruise level, like 25, 26, 27, 28, 29, 30,000 feet above the sea level. And we're gonna cruise through some waypoints, make some turns, and we're gonna start to descend back to the airport elevation like 6 or 7,000 feet above the sea level, and we're gonna approach and land to the airport elevation like 1,430 feet above the sea level. We're gonna have the stars before that, as we are approaching at 6 and 7,000 feet, like 10 or 15 nautical miles away from the runway threshold. We're gonna have the stars as other further terminal arrival waypoints and fixes that include horizontal and vertical navigation fixes for the terminal, for the long final and short final approach and landing. They're gonna align us with the magnetic north pole heading of the runway 136 degrees, runway 14 in Zurich International Airport, Lszh in Switzerland. We're gonna have also the Islands localizer for that, the instrument landing system, the horizontal localizer and vertical glide slope that follows the radio frequency transmitters from the runway threshold antennas and using on board antennas of the aircraft. We're gonna have the ILS localizer cross. We're gonna have 9 degrees of pitch attitude for approach and landing, full flaps 35 degrees or 30, and about 160 or 170 knots of air speed for approach and landing with the landing gear extended. So you have also all these things. You're gonna see how we're gonna work them out. So I need to set up the flight management computer over here. You can see also these panels view. So we have a better view of the flight management computer over here. You can see also we have the mouse pad here if we need to use the cursor. So we have the index here. It's identity, position, performance, takeoff, approach, annunciate status, navigation data, flight plan, loaded traffic control route, load flight plan, save plan. So we have identity is Boeing 787 GNX engines over here. Index again. Position, we use the reference position and Lszh in Switzerland, the reference airport. You're gonna see the inertial reference position, GPS position. So we have the gate also. We need the index again. Performance. We're gonna use this before creating completing actually the flight plan. We can start creating it right now if we need. So we start with the Lszh, the departure airport, origin and destination. Copy paste. So we use runway 14 over here in Lszh airport. So you can see runway 14 route. So we have departure over here from this airport. We can use either runway 10, 16, 28, 32, 14. So we select runway 14 over here, and the seats, these are the ultimate departure waypoints and fixes that include horizontal vertical navigation fixes and speed constraint. Then we have arrivals. We're gonna select arrivals to complete the flight plan. So we have VOM 16, 28, VOM 34, ILS 14, ILS 16, ILS 28, ILS 34 over here, GLS 14, localizer 28, 34. So we're gonna select ILS 14 again, Trans Negria, Trans Amity actually, Trans Amity. So we're gonna have the stars, the Negria here, and the star Trans Amity. So this is the stars and other terminal arrival waypoints and fixes. So we're gonna have here the flight plan is complete as far as I can see. There is no discontinuity. So this is the first waypoint, second, third, fourth. As we climb, then cruise, we need to complete over here 0 fuel on board plus fuel on board. We're gonna have the calculations and gross weight of the aircraft for this flight. So we're gonna have the calculations of fuel on board reserves 5%, cruising altitude 35,300 feet over here, cost index 100% over here. So it's gonna give us fuel freezing temperature, minus 37 degrees in flight, and cruising center of gravity 28% over here. So you activate, you use this page, you execute, you see the purple is displayed in the first waypoint. It's gonna be over here, 136 degrees, 1900 alpha, then Zui, 324 knots, 6000 alpha. We're gonna keep climbing a few waypoints. Nigria, Mach 0.76, 20 flight level 25,300 feet. It change heading 07. So we're gonna make a left turn here, then a right turn to Mativ. It's gonna be 12 nautical miles, flight level again to 25,300. Then we're gonna start the descent. Amiki, 190, 25,300. Then Zui, 187,000 alpha. Descent to the airport. This is the flight plan. One waypoint by another. Z8701, the stars. 180, 6,000 alpha. TRA, 185,000 alpha. CI14, 184,000 alpha. Osnem, 324, 4,000. Runway 14, 140, 1,455. So we're gonna land here, runway 14. So we initialize flaps 15 degrees over here. Takeoff reference is gonna give us center of gravity for takeoff and trim stabilizer. You can see automatic here. And the takeoff speeds, runway position, V1, V rotate, and V2, 140 knots, V2, V rotate, 130, gross weight, 357,000 pounds. So this is again the route completed. Alternate VNAV, a few more functions that we have: VNAV, progress, FMC communications, hold. We can hold in a waypoint. We select here, in-flight, legs, fix, navigation, radio. So this is all the functions we have from the flight management computer. We go now into the cockpit. I will show you a couple more things before going into flight. We need to set up. So you will see here how we're gonna set up the last things before going into flight. You can see here in the navigation displays, now we have the display of the flight plan, the primary flight display here in the HSI. Also here, as you can see, the data we have, the waypoints we have to cross as we fly, Osnem, the 8701, the VORS, ADFs, right, ground speed. So we have also the vertical here in the navigation display, how far above we're gonna be flying above the ground, the terrain. You can see red, green, yellow, the terrain elevation, and the flight plan. You can see some war station or airports. So we have the airports now, terrain, VSD. So we have, if we look closer, you will see you can use also the center display. You can see a better look of the flight plan here that we have created. This purple line, we're gonna be flying in the air or using the autopilot flight director. System panel is gonna be flying from takeoff, climb, cruise. Over here, descent, approach, landing, automatically if we need, or manually. So you can see both vertical, horizontal here, and vertical. So you can see how far above the ground we have been flying. Over here, you can see here is Germany, here is France, here is Switzerland in the terrain map. So it sends over here the range. You can see the furthest waypoint we're gonna be flying: Nigria, Mativ, Amiki, Zui. Over here, Osnem for approach now. So we'll look a little bit closer look, intercept. You can see the range here. So the range now is like 20 nautical miles over here. The ground speed also displayed. So you can see 20 nautical miles. Also the terrain in front of you when you fly. You can make an avoidance, like a couple of nautical miles in front of you. You have some mountains you need to climb. So look closer. You will see also we have the runway here displayed that we're gonna use for takeoff and for landing. The taxiway, the aircraft where is located, the other runway. Again, so you see the taxiway in front of you is this one taxiway from the GPS. Also the runway is over here displayed as it should be in the display. Also the other runway over here. So you can see the display here is what you can see if you look outside, with the taxiways and the runways and the mountains in front of you, the terrain. So this is for navigation purposes of the aircraft. Over here the GPS display and the air data over here I'm gonna talk to you about now. So we have you can see again the terrain a little bit better, the green, yellow, later red if it is above you too much. So you can see the terrain in front of you, like you have a couple of mountains here further away. So we will look also this display here. So we'll look also the plan display over here, as you can see. So you can see without the terrain, that's the plan. Nigria, Mickey, Mati over here. This is the cruise, this is the takeoff, climb, cruise, descent, approach over here, TRA, descent, approach and landing. This way, so we're gonna change again the range. We'll see a little bit better. So we need time to spend on these things to learn from takeoff. Here you can see the runway again, much closer, the aircraft symbol. Also the center display over here with a 360 degrees view. So we used also these instruments to change the range of the map, the plan display, also some systems from the aircraft here we need, we're gonna see later. We have inches of mercury, hectopascals, barometric pressure, radio minimums, barometric pressure for the altitude here, reject, cancel, some warnings over here, or accept. So you can see here we have the air data computer in the overhead panel, sharing a reference. So this is GPS receiver, magnetic North Pole, geographic North Pole, laser gyroscope alignment of the aircraft, air data, pitot static, pitot dynamic, attitude of the aircraft, laser gyroscopes, processing deceleration. So when you fly, you have the pitot static over here for the altitude and pitot dynamic for the airspeed. So you see vertical rate of climb, descent. All the air data is used using this air data computer and GPS receivers, and it creates this mixed display with the GPS and the terrain map from the radar. So you can see other things also. Autopilot flight director system panel. So we set up the flight management computer. We need only the thrust levers. I will show you the thrust from the engines, fuel control. So you see engines moving forward enough. You can see the engines, what they display. Autopilot flight director system panel. Then we go for takeoff. So we have the engines, GNX engines installed on our Boeing 787 jet aircraft. One in the left wing, one in the right wing for symmetrical thrust and redundancies. One contains the gearbox of the FADEX. The FADEX are the fuel authority. This is electronic control computers. One is to operate the gearbox, gloves and redundancy. One is on face, the other takes over, controls motors and displays on the engine data. You see in the upper and the lower ACAS sends indication across the system display on the multifunction display like PN1, which is the low speed soft low pressure compressor and turbine of the turbofan, which is engine, the exhaust gas temperature for engine, the N2, which is the high speed soft high pressure compressor and turbine of the turbofan, which is engine, the exhaust gas temperature for engine, the fuel flow rates per 1,000 kilograms per 1,000 pounds, solid pressure and temperature and quantity and vibration of the N2 stage of the engine. The Farix also control the fuel metering unit, engine start, engine shutdown, fuel flow to the engines, also the circulation of the fuel from the wing tanks and the center tank. We need a heat of fuel to heat up the fuel in flight, so we will avoid freezing fuel. We have the recirculation system from the wing tanks into the engine components to duct heat from the engine components and heat up the fuel. Also we do the same for the lubricant and the oil in flight. This is done also automatically using the Farix, the full authority. These electronic control computers. So you can see here also we have the hydraulics, the pressurizer, the Farix control many things, pressurization, hydraulic fluid tanks. So we have also pressurization of hydraulic fluid tanks. We have the APU. We're gonna start the APU to start the engines later. You're gonna see how. So we need pressurizer also. From the 5th and 9th stage of the high pressure compressor of the engines. So we have the pressurizer from this section of the engine to supply the cabin pressurization system, wing and engine RDIs, air conditioning, ventilation and oxygen regulation in the cabin and the cockpit. Also for hydraulic fluid tanks pressurization. You see here. When you move the flight controls, you have electric control using the flight control computers, but you have the hydraulic actuators also for other pedals, nozzle, steering, thrust, reverse, landing gear, external retract, parking brakes. So when you move the tail up and down, or the rudder, or the ailerons, spoilers, flaps, speed brakes, so you have hydraulic fluid tanks to pressurize over here. You can see. You have also the pumps, demand primary, from which are engine driven or electric driven. So we have also the Farix control, as I told you, engine pressure. We have an overpressure and under pressure. We can open and close the outflow valves, higher low position, the bleeder from the bypass also. And we have the PAX control. We have also as we climb the aircraft from the sea level all the way up to the cruise level, from 0 feet or the airport elevation to like 20, 30 or 40,000 feet above the sea level, like 8,000, 9,000, 10,000, 11,000, 12,000 meters above the sea level. As we climb higher, the pressure of the air, the oxygen level and the density of the air becomes less than half than that of the sea level. Also the aircraft will be flying with an airspeed rate like 2 or 3 times faster than that of the sea level. Also the temperature of the air will become freezing, minus 30, minus 40, minus 60, minus 50, minus 60 degrees below 0 Celsius. So we're gonna be having, because of the higher airspeed of the aircraft, also higher intake of air from the front fans of the jet engines for compression and combustion, and also for fuel air mixture. So we need a different fuel air mixture adjusted every second. It's adjusted automatically using the computers, the Farix computers, the electronic control computers, fuel air mixer. Also when we descend the aircraft by this back to the airport or the sea level, we need again a different fuel air mixer. So this is done automatically, not manually like they do in the propeller aircraft. So it's a good thing to have this in the jet aircraft. You have also other automations here. You will see autopilot flight director system panel. As I told you, the FS panel, so autopilot. Here you see autopilot and gates, disengage the LNAV and VNAV. So we have LNAV VNAV function. You can see this button. So we turn off the flight director here. You will see it's off this mode. We cannot rearm the autopilot without the flight director. So we have the auto throttle also, left and right over here. As you can see, auto throttle left, auto throttle right, on and off, climb continues, auto throttle, VNAV, flight level change. The airspeed here, we can set whatever speed we need. That is good to fly to. Autopilot engage, disengage. above the minimum airspeed, I believe. That is gonna make the aircraft stall. So we need bank angle, automatic heading. We're gonna use the magnetic north pole heading of the runway of the airport. We're gonna use for takeoff and for landing. Zurich International Airport, 136 degrees. Over here, altitude 35,000 approximately. So we'll set 25 and hundreds, 300 vertical speed, zeros, descend over here or climb the other way. So you see now the displays also the airspeed over here, indicated the altitude, the pitch altitude in flight over here, pitch altitude, bank angle in flight, airspeed selected, barometric altitude, altitude selected, vertical rate of climb descent 10,000 feet per minute, radio altitude above ground level. So this is all the data we need. We're gonna make an engine start demonstration in a couple of minutes. We start the APU over here. We have the electrical battery, direct current, 120 to 200 volts, the IDGs, the great drive generator, left and right engine driving, 130,000 kilovolts, primary flight control computers in the auto position, heading reference or data computer, flight control surfaces. Over here, FD, towing power, FD power, passenger oxygen over here, window heat, rammer turbine, also we have hydraulics over here, left and right engine off. You will see the engine and primary in demand. What happens? We have the electric also, so we turn back on very quickly. You see the fault indication. So we have also the wing and engine at the ice over here, as you can see. We have the lighting system, the windshield wipers over here. So we have the recorders over here, the cargo and APU fire over here. As you can see, the engines, electronic engine control, normal and alternate mode, and auto start modes. So we have fuel jettison, we get down some fuel in flight. If we select this, if we arm this and select the nozzles and how much fuel to remain, we have the fuel tanks, left and right, wing fuel tank, center tank, crossfeed valve is off if we turn it on. Feed either engine, we have the pump right the tank, the balance, the fuel also. So we turn back. We have the bleeder, the packs from the bleeder, wing and engine radius, air conditioning, ventilation, oxygen, pressurization here, manual, we use outflow valves, and descent. We can use also automatic. So we have the engine's indications, 1 more minute. You see here we have the N1, which is low speed status of low pressure compressor, and 2 one of the turbofan to its engine, exhaust gas temperature per engine, and 2 high speed pressure, high speed starter and shaft, high pressure compressor, and 2 one of the turbofan to its engine, left and right fuel flow, per hour, oil pressure, oil temperature, oil quantity, vibration of the end 2 stage of the engine, gross weight, and also the bleeder, cabin pressurization here, cabin altitude, rate of climb descent. So you see also some warnings. So we turn back to the auto over here from manual. So we're gonna you see all these things now. We see in the overhead. We're gonna see them in the digital format over here before going for takeoff. So we have the digital display also, system, hydraulics, APU, oxygen, liquid cooling. So we have the electric here. You can see left and right engine, IDG, 130 to 200 volts, 400 Hz frequency, generator, APU, battery, voltage and APU battery. Over here main battery, as you can see, volts, generator, drive, hydraulics, where the hydraulic fluid goes, which system use it, left and right engine, electric C1 and C2, set of valves, 5000 psi left and right and center, quantity of hydraulic fluid, fuel left and right, wing fuel tank 11,000, center tank 11,000, total 33,000, 33,700. You can see where the left and right engine is fed from the center tank, the green line, or the wing tanks, The APU is fed from the left when using DC motor, so the low and high pressure fuel valves in the left and right engine are open. The crossfeed valve is off, but when we turn it on, can feed either engine with either pump or either tank. Also, the minimum fuel temperature over here, you can see, is minus 37 degrees, so we heat up the fuel in flight. Right now the fuel temperature is minus 3 degrees. So this is the fuel system information. The air also, pressurizer, packs. Doors are closed over here. The cabin can be pressurized, the gear, the temperature of the brakes and the pressure of the tires. Flight controls, very important. Here you see the flight controls are moving. When move them, flight controls, rudder pedals, the yokes, everything is moving here in the display as it should be. The tail and the horizontal stabilizer. So we have everything display over here. Maintenance systems, circuit breakers, automatic, and last thing the checklist before takeoff, before start, after takeoff, cruise, descent, approach, landing. So we have the electronic also communications navigation display over here. So we turn off both engines before going into flight. So fuel control over here, both engines off. You will see what happens very quickly. So we'll go into flight like this. You can see the warnings here. Now we start the auto start system very quickly. You see the auto start. So you see the yellow reconfigurations in the overhead panel. You can see we have pressurizer from the left and right engine to 80%. You can hear the roaring of the engines. So we let the fuel control over here, left and right engine, both controls on. So we have the auto start now of the engines, as you can see. So we have the hydraulics back on. So we have at about 64%. We have the engines running over here. So we can go for takeoff. Flaps for takeoff now. Parking brakes off. Advance the thruster levers. Forward and go. We take the clearance from the air traffic control. So we advance. So we use the tiller over here for alignment. We take the clearance from the air traffic control. The runway is open. So we align now with the tiller, as you can see over here. Advance the thrust levers all the way up. We take off ground thrust. So we are in the takeoff roll. Press the rudder. Press actually the yoke a little bit down. 100 knots, 110. V1. We rotate slightly, 9 degrees. So we have the rotation. So we have the positive rate of climb over here, as you can see. So we have the positive rate of climb, landing gear up over here. As you can see, we are above 2,400 feet above the ground level. The indications: the airspeed 173 knots, the rate of climb crossing 4,400 feet per minute, the stall speed here with yellow and red, the wind direction here and speed, the engines indication also, left and right engine, the flight plan, and how far above we are from the terrain. Right now the aircraft is flying like 3,000 feet above, 4,000 feet above the terrain level, as you can see. So you can see also a little bit further away the flight plan again. Again, you'll see the terrain displayed, red, green, and yellow, as you can see. So we need to follow the flight plan now. So we keep climbing. This is runway behind the Switzerland, the lakes. Over here, very beautiful view. So we're gonna follow the turn. I'm gonna start the turn, the Swiss Alps, for following the flight plan. So you see how we turn over here. So you can leave the hands off as we fly. From the flight controls there is no problem. So this is the view of the cockpit after takeoff. To make a small turn here, also is the other flight plan. Display over here, both displays. So you can see now we're gonna follow the flight plan. So make a small turn here. See how easy it is to turn, and you leave the flight controls off. There is no problem holding the flight controls. Level, again, flight controls off, no problem, because we have trimmed the aircraft and we have set the thrust we need, and we keep the attitude as we like it. It's also fly-by-wire aircraft, so you can trim and make some flight controls by itself. So we keep climbing here. We have a beautiful view of the Switzerland, the lakes, the Swiss Alps. We have the Germany here, my homeland, and the France, and the galactic view. And we need like 15 more minutes for the flight to end. Very, very beautiful view here. So we're gonna make the turn now. For following the flight plan, we almost align, as you can see, the Zuri. Small turn. We need to increase the airspeed a little bit. So make a small turn here, as you can see. So funnily enough, now we climb faster. As you can see, the airspeed again, very important, 162 knots, the stall speed. We need to climb a little bit faster, perhaps. We need 12 more minutes for the flight to end. So we keep climbing over here, over flying the lakes. So pitching up a little bit, the aircraft. Nice view again, the cockpit. So the outside view. We keep flying higher to 8,000 feet. We have the lake, the Germany in front of us, the Bayern Munich, the France over here. And the galaxy. So you can see the lake here, the Switzerland. So we're gonna make the turn now for going back home. As you can see, very easy. We also have reached the limits here for the flight plan. As you can see, the waypoints we need to follow in the air. So keep climbing over here. Use a little bit left rudder as we turn. So this is the turn here of the aircraft. We're flying the Swiss Alps, the lake over here, the Germany, Bayern Munich over here, and the France. So keep turning. So better view of the Swiss Alps also. So retract the flaps, pretty nice. In a couple of minutes maybe. So we're leveling off, as you can see, and we send flights off. We can fly if we need. We are almost 24,200 feet over here. So you will see now a beautiful view of the chemtrails over here created. The engine's vapors over here, as you can see, as we're flying over the lake here, the Switzerland, the Germany behind us, the France, and the galaxy view. Have a beautiful galactic view over here. So we need to start the descent in a couple of minutes. So we're gonna start retract the flaps and also pitch down the aircraft. Idle, a little bit idle thrust, pitch them down. You can see we need to follow the flight plan. So we have this beautiful view here as we fly again the chemtrails, as you can see. So we are descending, idle thrust. And we have 7 more minutes left for approach and landing. So we are a little bit over speed. So we need to cross this path here, this purple line, to approach and land into the airport as we are descending. So keep descending. We have a few more minutes left for approach and landing. So you see how we are in the turn right now, the aircraft. Over here is the turn, we need to take. Keep descending, as you can see. And we have 4 more minutes left, a little bit left rather now for the left turn. Over here. So we need to align more abruptly. Over here. Align with the runway heading. And we have 3 more minutes left. So we have some side wind time to time. You see what I mean? One gear down. into a line with the runway using rudder pedals also as we are descending. So you see how we will approach over here and land. So we have the runway here displayed. We have also the Lszh localizer, the display of all the information we need for approach and landing, and the Lszh localizer. Also use a little bit more flaps as we are approaching for landing. We have some side wind. We need to combat the side wind, a little bit more thrust. Right rudder now, left rudder. So combat the side wind component, the wind gust and the side wind that pushes the aircraft away from the runway center line. So this creates also maybe some turbulence from time to time. We need to increase the rate of descent a little bit, and we are ready to flare over here. As you can see, we are approaching for the touchdown. So we have the flare. So here's the flare, very beautiful, very smooth touchdown. So parking brakes here, aligned with the center line, and thrust reversers. So we use idle thrust and thrust reverse over here. So we're slowing down, as you can see, and we made a very beautiful landing. The aircraft, very smooth touchdown. You can see all the landing gear here. It's very safe. There is no breakouts of the wheels, any wheel. What I show you first, you can see the nose wheel, the landing gear behind it, no breakouts. So you can see also where we land.